Hey everyone, and welcome to this explainer. Today, we're diving into a genuinely fascinating breakthrough in how artificial intelligence handles the absolute avalanche of scientific research being published right now. We're exploring a brand new framework called collective scientific memory networks. You know, if you've ever felt completely overwhelmed by information overload, you are definitely not alone. Our brightest human scientists are literally drowning in data. And until now, even our most advanced AI tools have suffered from a really critical flaw: amnesia. They just can't remember what they learn. So we're going to look at exactly how we fix that.
Okay, let's dive into this. We've got a really clear roadmap for understanding how AI is moving from just basic retrieval to persistent memory. Here are our sections. Section 1 is the information overload. Section 2, AI's memory problem. Section 3, introducing collective scientific memory. Section 4, meet the AI agents, and finally, Section 5, the proof and the future.
All right. Section 1, the information overload.
Millions, literally millions. That's the number of research articles, conference papers, technical reports, and clinical studies published every single year. In the biomedical field especially, the rate of discovery is just staggering. It's a relentless, overwhelming flood of data, and keeping up is no longer just difficult, it has become physically impossible. Imagine being a biomedical researcher trying to find a cure for a complex disease. You can't manually read, verify, and synthesize millions of documents, right? Human experts simply cannot keep up with this pace manually.
Which brings us to Section 2, AI's memory problem.
Naturally, we've turned to technology to save us, specifically AI. But we have to confront a fatal flaw in our current tech. Right now, AI systems, like your large language models and retrieval augmented generation, or RAG systems, they act kind of like a brilliant but entirely forgetful intern. They're retrieval-based and totally task-oriented. You ask them a question, they scour the data, they give you this great answer in a temporary context, and then, boom, amnesia. They throw away everything they just learned. On the flip side, the proposed Collective Scientific Memory Network, or CSMN, is memory-based. It's evolving, it's persistent, and it permanently integrates validated knowledge.
So the crucial point is captured perfectly in this quote from the source material. The current systems are mainly used as transient reasoning systems to recall, analyze, and produce something without keeping up a dynamic representation of the valid scientific knowledge. Basically, because current AI lacks persistent memory, it wastes massive amounts of time repeating the exact same analysis over and over again for different users. And even worse, it completely fails to resolve conflicting scientific findings over time.
So how do we fix it? Let's get into Section 3, introducing collective scientific memory.
We're going to slow down for a second here because this is a massive paradigm shift. This is where we move away from AI as just a fancy search engine and transform it into something entirely different. Here's the formal definition. Collective Scientific Memory Networks, or CSMN, is a persistent multi-agent architecture that continually collects, verifies, amends, and retrieves scientific knowledge as an evolving memory graph. Put simply, this framework turns the AI from a static, question-answering machine into a persistent, collaborative laboratory of specialized scientists that constantly build on a shared foundation of knowledge.
Okay, so here's how a new discovery actually moves through the CSMN pipeline, chronologically. First step is knowledge acquisition, where raw data is pulled from a new biomedical paper. Second, we have evidence validation, where the system checks this new claim against the existing literature. Third is consensus formation, weighing multiple sources of evidence to see if the scientific community generally agrees. And finally, memory integration. This is where the validated fact actually becomes a permanent, connected piece of the AI's scientific memory graph.
Now, what's really interesting about this slide is the elegant math driving the whole process, the memory evolution equation. It looks like this: m at time t+1, so the future memory, equals the current memory, plus validated new discoveries minus obsolete knowledge. This specific, brilliant little formula mathematically ensures that the AI doesn't just passively hoard data like a digital pack rat. It actively forgets outdated, obsolete information and deliberately builds upon new, verified discoveries.
Moving right along to Section 4, meet the AI agents.
So who exactly is doing all this heavy lifting? We're going to continue treating this network like a real, bustling human laboratory. In a real lab, human scientists debate, they check each other's work, they resolve contradictions. Well, here, we have 6 specific AI agents doing the exact same thing computationally, to filter the signal from the noise. You've got the discovery agent pulling out new claims, the validation agent checking the evidence. If two papers disagree, which happens all the time, the contradiction resolution agent steps in to evaluate the conflict. The consensus agent aggregates everything, the memory curator permanently files it, and finally, the insight generation agent uses that rock-solid foundation to propose brand new scientific hypotheses.
Let's look a bit closer at how they handle those disagreements, because let's face it, science is full of them. This is the knowledge stability function, utilized heavily by that contradiction resolution agent. It calculates stability by dividing successful validations by the sum of successful validations plus contradictions. By using this formula, the AI doesn't just get confused or throw its hands up when two biomedical papers say opposite things. It systematically manages conflicting research, scoring its reliability so it knows exactly how much weight to give a specific piece of knowledge.
And before any new finding is officially committed to that permanent memory graph, the agents put it to the ultimate test using the Scientific Confidence Index, or SCI. They score the finding based on three things: its novelty, like is it actually new, its consensus, does the broader evidence agree, and its stability, does it hold up against contradictions. Only highly trusted, incredibly stable science survives this gauntlet to become a permanent part of the AI's memory.
Let's move to Section 5, the proof and the future, and see how this actually builds out in reality.
We've talked a lot about the theory and the math, but let's look at the actual experimental results from testing this framework in biomedical knowledge discovery. And this brilliantly illustrates the power of memory. If you track the knowledge retention score across multiple discovery cycles, notice how the traditional manual review and the standard RAG AI systems are completely flat. They don't learn over time. But the CSMN framework, that high growing bar on the right, because it utilizes a permanent memory graph, it actively grows and compounds its retained knowledge over time. It quite literally gets smarter with every single cycle. And that compounding knowledge directly impacts how useful the AI actually is in practice. Here we see the Discovery Utility Score, which measures the scientific value of the system's outputs. Traditional reviews score the lowest. Standard RAG and basic multi-agent systems are somewhat better, sure, but CSMN stands head and shoulders above the rest. Because it actually remembers what it learns and resolves contradictions, the CSMN framework generates much more useful, accurate, and impactful scientific discoveries than any other existing framework out there. So, what does all this mean? Why does this matter to you and me? Well, because of its memory, the insight generation agent can output some truly incredible things. It generates novel hypotheses, recommends treatments, analyzes massive trends, identifies emerging research, and summarizes vast amounts of evidence. Think about it. In the realm of biomedical intelligence, having a faster, contradiction-aware AI that continuously learns, that could literally lead to the rapid discovery of life-saving therapeutics. We're talking about a tool that could fundamentally accelerate the pace of human scientific achievement. I want to leave you with this final thought to chew on. What happens when AI doesn't just search for science, but actually remembers it? We are standing right at the edge of an entirely new era of autonomous, continuous learning research ecosystems. It's a fundamental shift in how we discover the truth about our world. Thank you so much for joining me on this explainer, and keep exploring.